Hey guys, it's your first notes video. So here I have your first 2 pages of notes. This is the real numbers, classifying real numbers. And then the second page here is the properties of real numbers, okay? So I've already filled some stuff in to save on time. We're looking at the real number system, which is represented by this R there. So every time you see an R that looks like that, they're talking about the real number set, okay? And then we're going to look at how to classify them a little more in depth, okay? So you can read this top part here about irrational numbers, rational numbers, and then the subsets here, integers, whole numbers, and natural numbers. But I also break it down for you in this table over here in some different words, okay? So make sure maybe you want to pause this video at different times so that you can copy down what I already have in here. So we're going to look at, we're going to start with natural numbers here. Oops, that was really big. We're going to start with natural numbers here. Okay, this is the smallest subset of real numbers. And these are your counting numbers, okay? So when you start counting things like 1, 2, 3, 4, and so on, okay? Counting numbers. Those are your natural numbers, okay? And they are represented by this N here. So the N represents the natural number set. Whole numbers, so it will go up 1. Whole numbers are all of your natural numbers, so all of your counting numbers, including 0. Okay, so it's the same as natural numbers. We're just going to start at 0. So it's going to go 0, 1, 2, 3, 4, and so on. Okay, moving up to integers. Integers include all of your whole numbers and their opposites. And by opposites, I mean they're negative numbers, okay? So whole numbers include like -3, -2, -1. It includes 0, 1, 2, and 3, and so on. So these dots, these 3 dots at the end in the beginning means it continues in both directions with that same pattern. So -4, -5, +4, and +5. Those are all integers, okay? Our rational numbers are all of your integers, which are your natural and your whole numbers, and also including any numbers that can be written as a fraction, or numbers with repeating or terminating decimals, okay? So what this looks like is if I had like a decimal 0.34, and that's it. Like it doesn't keep going, that's a rational number. Okay, if I had a fraction 1 and 5/8, that's a rational number. If I had a decimal 0.2 with this repeating bar, so that means it's 0.2222 on forever, that is considered a rational number. And anything like that, so -7/10, say, anything like that, okay? These are all rational numbers. And then, so rational numbers include integers, whole numbers, and natural numbers. The other set in the real number system would be irrational numbers, okay? And this, like it says up here, are all other numbers, okay? So So E is a number that is irrational, okay? It has a decimal that goes on forever and it never repeats or terminates, okay? So E is an example. Pi is always a great example. Pi is irrational. We know that it has a decimal that goes on forever, never ends or repeats. And another easy way to pick out irrational numbers are square roots of any numbers that are not perfect squares. Okay, so perfect squares are like 1, 4, 9, 16, and so on. That you can take the square root of those numbers and get a whole number. So any number that you take the square root of that you don't get a whole number, those are also irrational numbers. Okay, pretty simple there. So there is your definition of all of them. And again, you can read this area up here. It gives it to you in a different way. Let's look at this graphic organizer over here, okay? So all of these, we're looking at the real number system, okay? So everything inside the box are all real numbers, okay? And let's look at the smallest circle over here. So the smallest set of real numbers is going to be your natural numbers that we talked about. okay? Natural numbers. Then just above that are whole numbers, which we already said that our whole numbers include the natural numbers, right? So you can see that in here. Natural numbers are inside the whole numbers. Whole numbers are inside integers here. And then our integers are inside rational numbers. Okay? And the only one that's over here in the lonely little circle that isn't a part of this are our irrational numbers. Okay? Those aren't related to natural, whole, integers, or rational at all. It's its own little thing. But they all fit inside this rectangle box of real numbers. Okay. So here, your first set of practice is name all sets to which each value belongs. So it always starts at the smallest. So -10, is it a natural number? Is it a counting number? No. Is it a whole number, which are 0 in your counting numbers? No. Is it an integer? Yes, it is an integer because integers are whole numbers and their opposites. So this is the opposite of +10. And an integer, by definition, is also a rational number, and it is also a real number. So it belongs to those three number sets. Now, the square root of 30. 30 is not a perfect square, so right off the bat we know that this is an irrational number. And the only other subset it could belong to is the real number set. Okay? So go ahead and do the rest of these practice problems before we move on. So if you need to pause the video, you can do that. I'm just going to keep moving on to the second page here, properties of real numbers. So all of these properties are things that you've seen before. We just want to make sure that you know what the names are and that you can use these properties when it comes to simplifying expressions and equations, okay? So I'm just going to run through these pretty quickly. Our commutative property says that we can add two numbers together. So a plus b is the same thing as b plus a. We just switch them. So this is the addition property, the commutative property of addition. And the commutative property of multiplication is the same thing but with multiplication. So a times b is the same thing as b times a. All right? Our associative property is saying that our associative property of addition is saying that if we have three things being added together, we can put the parentheses around any two of them. So if we put it around a plus b, and then we're adding c, it's the same thing as if we just move the parentheses over to the other two. They're all three being added, so it doesn't matter where those parentheses go. And with multiplication, it's the same idea, except you have three numbers that are all being multiplied together. So if we have parentheses around a times b, it's the same thing as putting the parentheses around the b times c. They're all being multiplied together. Okay, and then the identity property, so we call this an additive inverse. So it says that, the additive identity says that a number plus 0 is equal to that number. Okay, so here we have a plus 0, that's equal to a. Super simple. And then the multiplication identity says that a number times 1 is equal to that number. Okay, so with your identities, you're starting with a number and you're ending with that same exact number. So it's either adding 0 or multiplying by 1. With the inverse, the additive inverse is something that you add to a number to equal 0. Okay, so for a, we're going to add negative a to a, and then we'll get 0. The multiplicative inverse is something you multiply by a number to get 1. Okay, so a times 1 over a is equal to 1. Okay, so negative a is the additive inverse of a, and 1 over a is the multiplicative inverse of a. And then we have our distributive property, which says that if you have a number in front of parentheses, you're multiplying by something in the parentheses, that this number will be multiplied by each item inside the parentheses. So we'll have a times b plus a times c. So these are all things that you've seen before, that you've been doing. We're just making sure that you can put a name to it and that you can identify it. Okay, so this number 13, name that property. We have three numbers here being multiplied together, and we're just moving the parentheses from here to here. Okay, so we can look at our table, or you might remember that this is the associative property. And because we're multiplying all these numbers together, it's the associative property of multiplication. Okay, and that is how you do the examples there. So it's going to ask you to name the properties in this section here. Okay, so use the table above to fill that out. Then you're going to, you'll be given a number here, -8, and you're going to find the additive inverse and the multiplicative inverse. So the additive inverse is a number that will add to this to equal 0. Okay, so we're going to add +8 to this number to get 0, and the multiplicative inverse will be a number that you multiply -8 by to get 1, and so we'll multiply by -1/8. Okay, and this does have to be negative because you're trying to get +1. So if the initial number is negative, you have to make your inverse negative as well to get a +1, and then 1/8 will give you 1. So the multiplicative inverse is -1/8. Okay, so do the same thing with the other 3 problems there. And then I just want to point out that this closure property, this bottom set, we're not going to cover in class. Okay, so I've X'd out of the notes. In my interactive notebook, you can see that I actually just cut this bottom part off of the page before I glued it into my notebook. Okay, so if you have any questions on these notes or how to do these examples, send me an email and I can do another video on some of the problems. Ask me in class. This also corresponds with your homework number 1. So once you fill in these notes, you can use these notes to complete homework number 1.